In this video, we learn how to solve two-step linear inequalities. Now, the type of linear inequality that we'll be dealing with here are the following. Things looking like ax plus b less than or equal to c, or even x over a plus b greater than or equal to c. Now, we'll work through a few examples of these, but first, let's remind ourselves of the important rule to remember. When we multiply or divide both sides of an inequality by a negative number, we must reverse the inequality symbol. Now, keeping that in mind, let's go ahead and work through some examples. Say we're given 2x minus 1 greater than 7. Now, to solve this, the first thing we'll do is get rid of the 1 on the left-hand side. And we can see that the 1 is being subtracted from the 2x, so to get rid of it, we need to add 1 to both sides. That's 2x minus 1 plus 1 greater than 7 plus 1. On the left-hand side, the 1's cancel out, leaving us with 2x greater than 7 plus 1, which is 8. Now we can see that x is being multiplied by 2, so to get rid of that 2, we need to divide both sides of the inequality by 2. That's 2x over 2 greater than 8 over 2. And now that leaves us with x greater than 4. And we can represent this on the number line as follows. We draw the number line. Say 0 is here and 4 is here. We place a dot above the 4, and we're looking at values of x which are greater than 4. So those are the values to the right of 4. And we leave the dot above the 4 empty to highlight the fact that 4 in this case is not included in the solution. Let's look at another one. 3 minus 4x less than or equal to negative 9. Now the first thing we'll do here is get rid of the 3 on the left-hand side. And we have positive 3 here, so we can think of that as a 3 which is being added to the left-hand side. And to get rid of it, we need to subtract 3 from each side. That's 3 minus 4x minus 3 less than or equal to negative 9 minus 3. Now on the left-hand side, the 3's cancel each other out, leaving us with negative 4x less than or equal to, well, negative 9 minus 3 is negative 12. And now we can see that x is being multiplied by negative 4. And so to get rid of that, we need to divide both sides by negative 4. But careful, we're going to divide by a negative. We therefore have to reverse the inequality symbol. So that's negative 4x over negative 4 greater than or equal to negative 12 over negative 4. On the left-hand side, we're left with x, which is greater than or equal to negative 12 divided by negative 4, which is 3. And so we can represent this solution on the number line. Say 0 is here, 3 is here. We place a dot above the 3. We're looking at values which are greater than or equal to 3, so those are the values to the right of 3. And in this case, 3 is included in the solution. Indeed, x can be greater than or equal to 3. So to highlight that, we fill in this little dot above the 3. Let's look at a couple more. Say we're given 2 minus x over 3 less than 1. Now the first thing we'll do is get rid of that 2 on the left-hand side, and it's a positive 2, so to get rid of it, we're going to subtract 2 from each side. So that's 2 minus x over 3 minus 2 less than 1 minus 2. Now on the left-hand side, the 2's cancel each other out, and that leaves us with negative x over 3 less than 1 minus 2, which is negative 1. And now it's important to notice that whether we write negative x over 3 or negative x over 3 or x over negative 3, these are all equivalent notations. So we can go ahead and think of this inequality as x over negative 3 less than negative 1. And this often just makes our life a little easier to do this. Now we can see that x is being divided by negative 3. So to get rid of that negative 3, we're going to multiply both sides by negative 3. But careful, we're multiplying by a negative now, so we must reverse the inequality symbol. That's negative 3 times x over negative 3 greater than negative 3 times negative 1. Now on the left-hand side, these negative 3's cancel each other out, leaving us with x greater than negative 3 times negative 1, which is 3. And so that's the solution. X must be greater than 3. Once more, we represent this on the number line. Say 0 is here, 3 is here. We place a dot above the 3, and the values greater than 3 are all the values to the right of 3. And we leave the dot empty to indicate that 3 is not part of the solution here. Let's look at the last example. X over 5 minus 2 greater than or equal to 3. Now here, the first thing we'll do is we'll get rid of that 2 on the left-hand side. And that 2 is being subtracted from the term with an x. So to get rid of it, we'll add 2 to both sides. And that's x over 5 minus 2 plus 2 greater than or equal to 3 plus 2. Now on the left-hand side, these 2's cancel each other out, and that leaves us with x over 5 greater than or equal to 5. Now we can see that x is being divided by 5, so to get rid of that 5, we need to multiply both sides by 5. That's 5 times x over 5 greater than or equal to 5 times 5. Now on the left-hand side, these 5's cancel each other out, and we're left with x greater than or equal to 5 times 5, and that's 25. So x must be greater than or equal to 25. Finally, we represent this on the number line. Say 0 is here, 25 is here. We place a dot above the 25, and we're looking at values greater than or equal to 25. So those are the values to the right here. And we fill in the dot to highlight the fact that 25 is part of the solution. Indeed, x is greater than or equal to 25. And there we go. That's how we can solve two-step linear inequalities. I hope that helps.